Hello, I'm Kate Kim.
And my name is Jovanay Carter.
We're presenting our final project for Python programming class at the University of Chicago's Master's Program in Computer Science.
Our project, which we're calling Friendly Foods, is a food allergen detection API designed to help people with allergy restrictions navigate food choices safely and easily.
In this walkthrough, we will first talk about how we came up with the project idea and introduce the practical uses of our API. We will go through a demo of the program, go through our backend development process, and lastly, walk you through some of the challenges, trade-offs, and additional tools we used beyond our coursework. Let's get started. The idea for this project was driven by my son's severe food allergies. As a mom, navigating grocery aisles while ensuring his safety has been a constant challenge, motivating me to create a solution that makes shopping safer and more reassuring for families like ours.
Kate's family is one of 32 million in the US with food allergies and 10% of the global population. So we know that placing preventative measures can be a very helpful tool for many families. Some practical ways we imagine our API being useful include grocery store shopping. Instead of needing to read ingredients yourself, users will be able to scan a product's barcode while browsing in a grocery store aisle, or even download a Chrome extension that would show if the product is safe or not for their allergy restrictions. Beyond shopping, our API can be integrated into allergen tracking apps or health apps to monitor and avoid harmful foods. Or for international travelers, this API could be really helpful to learn if a new product contains harmful ingredients. Even though our product is currently English-based, it could be an implementation for the future.
So let's walk through our demo. Our API analyzes food product data against allergens that a user specifies. First, let's create a user. For example, we have a user whose name is Sarah, and she creates a very secure password. And after that, we need to log in under that username and password in order to scan the products. Here, Sarah can create an allergy. Say she's allergic to soy. She enters soy. And then if she wants to see what her allergies are currently in her profile, she can execute and get that soy is in her allergies list. Then imagine Sarah went shopping and came across a product and she's not sure whether she can eat it safely or not. She scans the barcode and then she can see that the product is Oreo with the barcode, and this is her username, and the product unfortunately contains the allergen soy. So the product Oreo goes into her red category. If Sarah wants to access her history of product searches, she can do that by getting the history. And we can see that Oreo here is in her list of red products.
We can also do a few more backend things like delete the allergy. Sarah can insert soy. And we can see when she runs get allergies, we can see if it's still there. And as you see, her allergies list is empty, so she's no longer allergic to soy. Yippee. We can also delete the user. So Sarah can say, I am free of my allergy. I don't want to be involved in this app anymore. And if we go to read users, then there are no other users, which means Sarah's profile was deleted. So that's a bit of a walkthrough. Those are most of the applications on our user side. And now we'll walk through some of the back end.
So going into the back end of how our program runs, we wanted to keep in mind what the user experience and customer journey would be, so we tried to make it as simple as possible for the user. We started with the core parts of the program, which were the product, the user, and the allergies. In the product class, we pull the data from two main food databases. The first one is the USDA, from where we would fetch the name of the product by the barcode and get a JSON response. And the second source is the Open Food Facts. And the first challenge that we came up with is that neither of the databases contained all the information that we needed. That is why we're using two databases. And the second challenge that we came up with is the allergy information from Open Foods was not consistent. For example, we saw a peanut butter jar that did not list peanuts as a top 9 allergy in the allergy list, which is why we cross-check the top 9 allergy classes within the ingredients list. And for that, we created an allergy class that has the top 9 categories listed with the alternative names behind which the allergy can hide in the ingredients list.
We also, okay. We also, on the user class side, the user class takes in their allergy and a product and returns a color-coded description of safety, which can be green for safe, yellow for caution, or red for not safe. As you saw, Sarah had red for not safe product. How we do this is we run the comparisons from the user class, which if you go into, so when we get into the user class, what happens is, well, first we ran into a third challenge, which was that some of the users might enter, the users have the opportunity to enter anything as their allergen. They could enter something that's in our top 9 categories, such as milk, or they could enter something that is an alternative name, such as whey. But some of the allergens are not correlated in that if you're allergic to whey, you're automatically allergic to milk. If you are, for instance, allergic to almonds, you're not automatically allergic to all tree nuts, such as coconuts. And so in order to assess for this edge case, we added this cautionary category program flow to make sure that we kept up with any allergens that required caution. The rest of the methods in the user class compare the user allergies and product allergies by using regular expression, and then we color code the products based on the results. So green, again, is safe. Yellow is saying that the product might have some trace of a relevant category, and then red says the product is not safe.
Then for the databases, we decided to go with SQLite. And here in the database.py file, we can see that we're setting up all the connection processes to our SQLite database. In the models.py file, we are defining our ORM classes that map to actual database tables, also known as the SQL Alchemy models. And in the schemas.py file is the file where we create the Pydantic models to define a valid data shape.
For our endpoints, as you saw on the user end, we use FastAPI in our crude files connects to main, and both of them allow create methods for the user to create, read, update, and delete their information. In the main file, we make sure to make sure that we check to see if the user is logged in across different posts. As you saw, we had to do an authorization to make sure that the user was logged in order to add an allergy, in order to delete the allergy, etc.
And then we have some other files. The requirements tells which programs which modules are needed to be installed in order for the program to run smoothly. And the test files have some testings that we used to make sure that our program is working the way we want it to work.
So in conclusion, our Friendly Foods Food Allergen Detection API helped us to think deeply about databases, user flow, teamwork, Git management, and food allergies. It also helped us to learn new technologies outside of class, including Pillow Library for barcode detection, image recognition, Python, Jose, and OAuth for secure token authentication. And then we also use SQLite for our database.
And some additional things that we would want to implement, it would be adding images so that the user recognizes what the product he searched for, adding diets, for example, vegan, vegetarian, and also adding manufacturing facility cautionary information for cross-contact information, and support international food markets. And of course, adding a more elaborate front-end user flow. Thank you for watching.
Thank you.